Welcome to Web Handling. My name is Dave Roysum. This is a continuation of a short series on web machine safety. In the last clip, we covered some case histories of serious accidents on web machines, as well as a few best practices to avoid them. In this clip, we talk briefly about codes and standards. What I and many others have observed is that, thankfully, the number of serious accidents has decreased quite noticeably over the last 200 years. Whether this is due to awareness, codes and standards such as discussed here, practices such as discussed last time, lawyers, or some combination, is hard to say. Yet, this trend to fewer deaths is slowing. We still have the occasional serious accident, at least some of which are preventable, perhaps by the ever-evolving codes we discuss here. I must acknowledge that the next few slides are entirely the hard work and skills of Clarence Clausen, who has graciously allowed me to use them for the good of all. However, these codes and standards are ever-evolving and ever-changing and can be difficult to keep up with. See Clarence's AMCA blog for the latest annual update to this list. The American National Standards Institute was formed in 1918 as a way to improve interchangeability of parts and measurements, as well as to improve quality. About 20 years ago, they started to take on web machine safety in earnest. While these codes originated in the film industries, other industries may also be guided and bound by them when applicable. The German Institute for Standardization is the German ISO member body. Similar in many ways to ANSI, its founding a year earlier was to improve interchangeability. Similar to ANSI, it took on safety about 20 years ago, but primarily in the paper industry rather than film. CEN and related organizations are more recent, but in many ways more stringent, at least in regard to safety. Being able to quickly and safely stop moving machinery is a must. However, what quickly means depends greatly on which machine you are referring to. While your lawnmowers are now required by the U.S. Consumer Protection Safety Commission to stop blades running at top speed within 3 seconds, paper machinery could take the better part of 3 minutes to bring their machine to a stop. The reason for the difference is the multi-million-fold increase in large rotating roll inertias, which makes stopping in seconds quite practically impossible. Thus, current best practices is a maximum safe deceleration of all drive points, perhaps sized for no less than 300 feet per minute per second or 100 meters per minute per second. Finally, there are many other useful safety codes and standards. One of the most recent areas is risk assessment. This was loosely derived from the aviation industry, who developed failure modes and effects criticality analysis methods decades ago. It tries to anticipate failure modes, probability, criticality, and how to minimize each. Some components are safer than others. Here is a ranking from least to most safe. Stopping time was briefly mentioned earlier. Here are the categories that you are likely to run into on web machines. The typical equipment you find in the web industries has a category 0 or 1 rating. Much of the small equipment we see, such as power tools and compressors and our idler rollers, merely coast to a stop. Web machines usually have active braking via motors and mechanical brakes, or some combination, but only at their drive points. Internet searches reveal a plethora of web pages on stopping time measurement methods and requirements. However, I could not find any related to stopping rates. When I was working at Beloit, we sized motors and brakes for no less than 100 meters per minute per second for winders under e-stop conditions. Unfortunately, the high speeds and inertias on paper machine winders meant they took minutes to come to a stop, making the precise stopping rate somewhat of a moot point for mitigating the severity of accidents. Safe distance is a computation involving the factors that affect the required stopping time once a presence sensor detects an operator in its path. These are primarily involved at low or thread speeds. At higher speeds, we would need to fence the hazard areas, as stopping fast enough is practically impossible, as discussed earlier. There are many types of presence sensors that all have their pluses and minuses. Until recently, the safety mat was the most common. However, this is not a Category 4 component because it can fail open without notice. Also, they can be a maintenance nuisance by failing closed if somebody drops something on it. Light curtains seem to be the most common now. However, ultrasonics offer the advantage of a programmable perimeter. One thing we noted last time is that many, if not most, web machine accidents occur at a stop or jog or thread speed, which is about the speed you walk at. Please see the previous clip to show why a crawling speed is so very dangerous. Do codes prevent accidents? Great question, but it should probably be rephrased as, do codes prevent some accidents? The answer to that question is certainly yes. Some accidents, but not all accidents. First, codes are not always clear as to when they apply and what they apply to. There are many loopholes when the industry has no safer solution. An example here is the guarding of a light airplane propeller is so inefficient that it would not allow the airplane to lift off the ground and is thus not required. However, guarding of props on airboats and some powered parachutes can allow function and is thus the norm. Risk assessments try to anticipate accident modes, but the process, being an entirely human endeavor, is imperfect. We don't have a perfect crystal ball. There is a gallows humor joke that states if you make an 8-foot fence, the operator will find a 10-foot ladder to go over it. There is a similar joke about warning labels on those ladders. Also, perhaps most salient for most of you is that older machinery may not need to be compliant to newer standards. With only one OSHA inspector for every 60,000 industrial workers, it is very unlikely that some government inspector coming in unannounced and inspecting your machine for compliance with the latest codes listed here. Yet, that is exactly what is done in other industries, such as the FDA for drugs and for the USDA for food processing plants. None of the organizations mentioned above has much legal authority or much of any enforcement mechanism. An exception here is that some countries will require compliance for some sections of the code on some new machines, and they can enforce it. This is different than, for example, the FAA, who can require old airplanes to do inspections and replace parts that may have been in service for decades. However, if an accident occurs and the machine was not in compliance with code current at the time of commissioning, and non-compliance might have helped prevent the accident, then you may need to open your checkbook and ask the injured party how much they want the check made out for. Also, at that time, you will likely get a thorough inspection by government officials, that is, OSHA. Generally, codes can make workplaces safer. Generally, safety programs can make us safer. But you can still get hurt. Compliant behavior is not necessarily risk-free behavior. Be aware, be smart, and be safe. Finally, the small print. I am not a lawyer and have only a small amount of legal training. The personal injury laws for each U.S. state are different, and the laws are continually being updated. This is just my humble effort to keep you guys safe by being aware of what codes say that might guide you in best and safest practices. Do not take any advice here without consulting your safety department, legal department, your machine builder and their competitors, the literature, applicable state and federal and international codes, health providers, common sense concerns from your operating staff, etc., etc., etc. Thank you so very much for watching this module in my Plant Practical series. Yes, codes and standards can be tedious, perhaps even more than safety meetings, but they are designed to protect you from injury. They are, in part, responsible for the remarkable reduction in industrial accidents in our lifetime. Stay tuned for the next clip, where we will continue our discussion of safety.